Hello students, now in this video let us see the Bowley's coefficient of skewness. Now this is given by the Professor A.L. Bowley measure of skewness. His measure of skewness is based on the quartiles. The quartiles. In a symmetrical distribution, the distance between the first quartile and median is equal to the distance between the median and the third quartile. That is median minus Q1 equal to Q3 minus what? Median. But in skewed distribution, the quartiles will not be equidistant from the median. Professor Bowley has given a result or given a formula as, first of all, he has given the Bowley's absolute measure of skewness. That is what? Q3 plus Q1 minus 2 times median. This is what? The absolute measure of skewness. Now the another part, Bowley's relative measure of skewness based on quartiles is known as Bowley's coefficient of skewness. It is denoted by SKB. and SKB equal to what? This is equivalent to Q3 minus median minus Q2 Q1 upon what? Q3 minus median plus median minus Q1. Okay, that is equivalent to what? Q3, here we get plus Q1, that is absolute measure we are getting at numerator, 2 minus what? Median. Upon denominator this median get cancelled, so it will be Q3 minus Q1, difference between the third quartile and the first quartile. As such we get the result of SKB or Bowley's coefficient of skewness. Okay, now let us see the interpretation from this result. What we get from this result? The interpretation. So if SKB is positive, the distribution is positively skewed. If SKB is less than 0, the distribution is negatively skewed. And if it is 0, the distribution is symmetric. This is what? Symmetric in that case. Now it is just like Pearson's coefficient of skewness. Here also, if this value is positive, the distribution is positively skewed. If it is negative, the distribution is negatively skewed, or 0, then it is symmetric. But there are some remarks. Let us see the remarks. Or one more thing I want to tell, we are unable to compare the Pearson's coefficient of skewness and the Bowley's coefficient of skewness, because that one depend on measures of central tendency and this one depend on what? Quartiles. So now first remark, Bowley's coefficient of skewness is useful when the distribution has open-end classes or unequal class intervals or extreme observations are present in the data. In those situations, the Pearson's coefficient of skewness cannot be used. Bowley's coefficient of skewness is useful when the distribution has open-end classes or unequal class intervals or extreme observations. Extreme observations are present in data. In such a situations, in such a situations, Carl Pearson's coefficient of skewness cannot be used. Now second, the Bowley's coefficient ranges from -1 to +1. That is -1 less equal SKB less equal 1, just like Carl Pearson's coefficient of skewness. Now the next one, the Bowley's coefficient of skewness is based on quartiles, or actually it is based on middle or the central 50% of the data, is based on only the central 50% of the data. Next one, the values of the coefficient of skewness, obtained by Bowley's formula and Pearson's formula are not comparable. We cannot compare those things because both of them are what? Different. Comparable. But in each case, when skewness is what? 0, that implies the distribution is what? Symmetric. The distribution is symmetric. This is the part there only. Fine. Now let us see the examples. Now for quartiles also we have seen a box plot to represent quartiles. So sometimes the question will be asked to express the distribution using box plot also. So let me take the example for that kind first. So for two distributions A and B, for the following data, now what is the data? A, B with us. Now median is given. Median is nothing but Q2, Q1, Q3, minimum and maximum of that one is given to us for the distribution. Okay. So here 20, 13, 30, 10 and 35. Here it will be 24, 14, 31, 10 and 35. Now what is the question? Compare the skewness of two distributions using box plot. Already when we have discussed positive skewness and negative skewness, that time also those things I have been given in terms of box plot. So what is the solution here? Here let me express the first distribution as a box plot. Now, minimum is 10, maximum is 35. So let me take here 10, here 15, 20, 25, 30 and suppose here 35. Okay. So 10 is what? Minimum. So let me take a point here. Here it is maximum. Okay. So now what is other? Q1 is 13. So it will be somewhere here. Okay. It will be 13. 13. Now median 20. This is a median here. Fine. It is with us. Now next one Q3 is 30. So this one with us. So let me prepare lines just about them. Here we have to prepare a box. This is known to you. And here these things we will join. This is what? Q1, this is Q2 and this is Q3. Now if you look it carefully, Q2 minus Q1 is less than Q3 minus what? Q2. This part is what? Bigger one rather than this subtraction. So means what? This is positively skewed. Median, here this difference, according to the difference we will see. Here we can say this is what? A box plot. Box plot for what? A. Box plot for A. And here it shows positive skewness. Positive skewness. Okay. Now similarly let us see for B. Now again here also minimum is what? 10 and maximum 35. So 10, suppose 15, 20, 25, 30 and suppose here 35. Okay. So now here suppose here the minimum and what? Maximum. Okay. So now 14. So here it will be Q1, suppose it is what? 14. Now 31. So it will be here. This is what? 31. And 24. So it is somewhere here. 24. So here and here we will get. So let us prepare a box here. So this is Q1, Q2 and what? Q3. Now look at them carefully. Here this difference is bigger than this one. So here this is a box plot for what? B, and this shows negative skewness. This shows negative skewness. Okay. As such we can determine the skewness from the box plot also. Okay. Now let me take the next example. Find the coefficient of skewness from the following distribution. From the following distribution. Difference between upper and lower quartiles equal to what? 8. Mode equal to 11. Sum of upper and lower quartile equal to 22. Mean equal to 8. So let us see the solution. We have to find what? Coefficient of skewness. Now difference between quartiles is given, means obviously the Bowley's coefficient of skewness is asked to us. So now first of all let Q1 and Q3 are lower and upper quartiles. Lower and upper quartiles respectively. Okay. Given to us, what is given? Difference between upper and lower quartile. So Q3 minus Q1 is how much? 8. Mode is what? 11. Then sum of the quartiles, upper and lower. Q3 plus Q1 is how much? 22. And the mean is what? 8. Now here we need to determine median for, we have to find SKB. What does the result for that? Q1 plus Q3 minus 2 times median upon Q3 minus Q1. This one we have to determine. Okay. So here we have Q3 plus Q1 with us. We have Q3 minus Q1 with us. So one thing is left, that is median. So for that mode and mean is given to us. We can easily determine median using empirical relation. So by empirical relation, mean minus mode equal to 3 times mean minus what? Median. So this gives median equal to 2 times mean plus mode upon what? 3. So this is equivalent to what? 2 times mean means what? 8 plus mode is 11 upon 3. So this is 27 by 3. So from this we get median equal to what? 9. Okay. Now SKB. So what does this? Q3 plus Q3 plus Q1 or Q1 plus Q3. So it is 22 minus 2 times median is 9 upon this difference is how much? 8. So this will be 4 by 8. So this is 1 by 2. So it is 0.5. So this gives coefficient of skewness is what? 0.5 is here. Okay. Now let me take one more. The next example, for a data set, lower quartile is 30 and median is 40. If distribution is symmetric, find the value of upper quartile. Solution. Here given Q1 is what? 30. Q2, that is median, is what? 40. Now distribution is symmetric. This is very important. So this gives SKB is what? 0, since distribution is symmetric. Is what? Symmetric. This is the reason for that. Fine. And what is to find? To find what? Q3. That is our aim. Upper quartile. That's one we have to find. So now by Bowley's coefficient of skewness, SKB is what? Q3 plus Q1 minus 2 times what? Median upon Q3 minus Q1. Okay. So now this value is given as 0. So 0 equal to Q3 is not known to us, Q1 with us, that is 30, minus 2 times median with us, that is 40, upon again this is what? Q3 minus 30. But if we take this side, this one, so it will give us, this is what? 0. So this gives us Q3 plus 30 minus 2 times 40 equal to what? 0. So Q3 plus 30 minus 80 equal to what? 0. That is Q3 minus 50 equal to 0. So that is Q3 is equal to what? 50. This is our result here. Okay. Now here we will stop. In next video we will see some more examples on the same topic.